Okay, just going to go through some of the bits of the M1 paper that you sat last week, um, just to explain if there are any problems. Start with question one, which was the relatively easy one. You've got an aircraft on a runway AB of length 1.2 meters. Just realised that probably a little ruler to explain certain subtleties of the question might be helpful here. Um, so, if you are, there's an issue here because you've got the runway, which is AB, and A to B is 1.2 kilometers. But I think that the way in which the lettering was done made it slightly confusing because you have to be very careful here. AB is 1.2 kilometers. The airport starts on A, the aircraft, there's the plane, starts at A, and at some point will take off. Now it takes off before the end of the runway. I suppose you have to kind of think about logistically what's going to happen there. It takes off at point C. Let's see, not B, let's see. There you go. Which means that C is not the full length of the runway, and that poses a certain difficulty at the end of the question, which I'll come back to. First of all, the acceleration is pretty straightforward. It starts off at 2 meters per second and accelerates to 74 meters per second with constant acceleration after 20 seconds. I've written acceleration as dv by dt here. Hopefully you'll be comfortable with that idea that the rate of change of velocity is equal to acceleration, and we know that it's constant. Another way of thinking about it is it just comes from VUAT if v equals u plus at. And by definition, acceleration is the change of velocity over time. So I've just written as dv over dt. The velocity changes by 72, not 74. That's me not reading the question properly. And 72 over 20 is 3.6 meters per second. Here's the tricky bit. The distance BC is from B to C. It's from the end of the runway to the point where it takes off. Now, if you work out the distance from where it starts to where it takes off, the bit where it hits 74 meters per second, then you have to use this distance and subtract it from the distance of the whole runway to get BC, which is exactly what happens. If you do Sutterfat, so S equals ut plus a half at squared, then obviously ut is not included here. I've done well. So ut is 2 times 20 plus a half times the acceleration, 3.6 times 20 squared. Done well with my working here. The answer you get is 760, and that gives you the distance from here to here. You then subtract that from 1.2 kilometers, which equals 1200 meters, so 1200 minus 760, and that gives you 440. I should have corrected this before I showed it. Never mind. Hopefully that makes question one clear. 440 is the answer. Next we get on to our resolving parallel and perpendicular questions, which are pretty standard, and these ones you need to start getting familiar with. Let's see if we can get this so it's more or less vertical. Okay, super. Hopefully you can read all that. Now, clearly putting the correct forces on is essential. I've written this slightly differently. I've showed the perpendicular component of the weight here, which is 2g cos 20, and the parallel component of the weight here, 2g sine 20, with r as it always does, going perpendicular to the slope. And I've written 0.6 r here because we know that the coefficient of friction is 0.6. And the friction isn't always mu r. It is when something's moving or where it's about to move. So in this case, is the box moving? Yes, it's being pulled up a front rough plane. So because it's moving, the friction will be at its maximum, hence 0.6 r. So these are all the forces we need to know about. We've got the 18 Newton marked here. And so then we just resolve parallel and perpendicular. Which of these correspond to parallel and perpendicular? Hopefully you're happy with that. Generally you start by resolving perpendicular because there's no acceleration. So this r is going to be equal to this force going in the opposite direction. So it would be correct for me to write resolving perpendicular here, r equals 2g cos 60, so that's 2g cos 20, so which is 19.6 cos 20, which comes out as 18.418. And that answers question A. Pretty straightforward. Resolve perpendicular. The acceleration of the box comes from force equals ma. I've separated this into two stages. I've started by working out the net force F. This isn't necessarily the way I would write this down, but this is one way of splitting it up. So the net force is equal to this 18. It is moving up the slope. And so I think we can assume that it's accelerating up a slope. It's not necessarily the case, but yeah, this force is greater than the forces going the other way. So we do 18 minus 2g cos 20, the component of the weight going down the slope, and 0.6r. I've simplified the calculation here, which perhaps isn't entirely helpful. Maybe I should write that out. So, in fact, why don't I scrap this working and do it the way I normally would do it, because that would be better. I'll say, resolving horizontally, we've got 18 minus 2g cos 20 minus 0.6r is equal to ma. The mass is 2, so this is going to be equal to 2a. And we are finding a. Now, we know all the other bits. We know what g is, we know what r is. So we do 18 minus 19.6 cos 20 minus 0.6 times r, which we worked out in the first bit, which is 18.418, equals 2a. And what we get from all that is 0.2456 equals 2a. That's 18 minus 19.6 cos 20 minus 0.6 times the reaction force. So this resolving perpendicularly, I've made it the net force, which is this minus this, is equal to ma. And really, this is what you need to be writing. If you can get to the stage where you can resolve parallel and say the net force is equal to ma, you're going to be able to answer questions like this. So there's this general format. Start by resolving perpendicular, make the reaction force equal to the perpendicular component of the weight, and hence work out the reaction force. Once you know the reaction force, then you can work out the friction, and so you say net force is equal to ma. You go through the same process every time. Obviously, if 0.2456 is 2a, then you can go down here, and a is 0.123. But that is a standard question, and that's the way that I would suggest you work it out every time.